All right, welcome to Chapter 8, Section 4, called Surface Area of Cylinders. This is for Math 8. So the first couple things you'll see on your screen here. The first thing you should see as a student is a due date. You don't see it on my teacher preview here, but you'll see it on your student screen. Number of attempts is the second thing on the screen. You always have unlimited attempts on homework, tests, and quizzes, so you can come in and complete them as many times as you would like. Number of questions just tells you how many questions are in this assignment. Grading policy is always best score. So whichever attempt is the best one is the one you get to keep. Partial credit is always enabled. So if you answer one of two questions correctly, you get credit for the one question. Down here it says, please remember once you start your homework, you must finish it before you can work on anything else. So that means once I click start, down here in the bottom right corner, there is going to be a submit assignment button. So you always want to make sure that you click that submit assignment button when you're ready to leave the screen. So by leave the screen, I mean close the tab, close your computer, whatever it is you're doing, or even walking away from your computer because it'll log you out. If you don't click submit assignment, Alex will assume you want to leave this attempt open and it will lock all of your other assignments until you come back to this one. Remember, you have unlimited attempts. There's no reason to leave this one open. And as long as you have green check marks here, it's not going to make you repeat them. If you haven't answered anything, you're going to go back and redo them. So make sure, big reason there is, first big reason is it'll lock you out of all your assignments, so click that button. Second big reason to click that button is it actually affects the gradebook when you click submit assignment. Before you click that button, it's kind of like your account's frozen. Your teacher can't even see what you've been working on. So two big reasons to make sure you click that button when you're leaving. On the side here, you have explanation, example, and message center. So explanation tells me I'm going to lose my question attempt because it's literally going to give me the solution to this question. So you're not going to get the solution and then, get to come and type it in. That's not how this works. But example, we'll show you an example of exactly what it is, or not exactly, but pretty close to what it is we're looking at, and even shows you these kind of different three-dimensional shapes expanded. And I'm going to show you that on another screen too, where we actually get to see the interactivity of that, which is pretty cool. And hopefully in class you've been playing with these for the last couple of weeks. I know they've been included in the SRGs, so it's something that we should hopefully be getting used to. The idea of a net into an actual three-dimensional object. And the net is just, what does it look like if I could cut it open and flatten it out? That's what a net means. Not a net, it's a net. Sorry, not the name a net. All right, and then we also have message center, so you can message your teacher directly from the screen, and it attaches a picture so that they can, see what you've been working on and where you need help. All right, let's go ahead and look at these. So there are three solids. We have these three solids here, and we need to decide which net they belong to. So I like a couple of these interactivities here. So if we look at some of these pieces here, and I'm just going to go with a couple. So I have this rectangular prism, and I can see here, and it's already showing me the net for this rectangular prism. And if I click play, I can actually see it being folded back up. So I can see the visual of why that's actually the net, or see it unfolded into this net. So for a rectangular prism, this is something that we're looking at. I've also, because I don't like this net as much, but this is a cube. So if I fold this guy back up, you can actually see it makes a box. So they have it kind of funny. I've never really seen a net look like this. Usually it's in this shape that we see on that other screen there, like this. So we can actually see that it's matching up here. This looks just kind of like this one. They're just a little skinnier on the sides and it's orientated a little different, but that's okay. So we're looking for a rectangular prism, which is a box. That's, the basic idea here. So this would be A. That definitely matches there. Be careful with this, because if they were cubes and this wasn't a cube, or if they were squares, sorry, and this was not squares, we wouldn't match those up. So we want them to be roughly the same shapes. So I can see like this is a skinny rectangle, here's a skinny rectangle. The top looks like a bigger rectangle, this looks like a bigger rectangle, and this looks like a bigger rectangle. So we want to make sure that they do somewhat match up. For these other pieces here, so let's look at triangular prism. So triangular prism, we have two triangles, one on either side. So in this case, front or back, or it could be the top or the bottom. And then we have rectangles for all the other sides here. So we can see that kind of spinning around. And if we look at the net for this one, I can fold this up and it folds up the triangular sides and then into this piece. So I can see that triangular piece there. And if I pause this, it doesn't show me the front view of it for whatever reason, but I can see It has 3 rectangles or squares if they were squares, but these should be more rectangular because these are rectangular. And then 2 triangles. So I can definitely see that that's this guy here in the middle. But up here, I don't see a rectangular prism. If you notice, this doesn't come to a point. Ah, dang it, stop it. It doesn't come to a point at the top of the triangle. It has a line. So that's not a prism. So this is none. This guy doesn't match any of them. Let's go over here because I have to scooch over to do the other one here. So if I'm looking at a cylinder, so that's just a can, which we definitely have. I don't know if I can, I don't think I can turn it sideways. But we have this cylinder here. So this one's tall. The one we have on our homework there is sideways. Not really a big deal as far as the orientation. So we would just want to see if I were to cut the can down the side, what shape would it make? So if I cut the can down the side and we flatten it out like this, we can see, come on, spin around. Why did it do that? That's a weird, I don't know why it moved that in. I didn't mean to move that in. Okay, it's just being funny now, but it still looks like it fits perfectly in there, so I'm not sure why it's overlapping. That should definitely not be overlapping. It should be up a little higher. So here, let's refresh it and try again. There we go. That's what it should look like. So they should be touching on the sides. It kind of looks like a division symbol almost. I can even turn it sideways so it looks like what we see on the screen over here. The idea is we have 2 circles and we have a rectangle. I've also seen that the circles kind of offset a little bit more. I don't know if it'll let me, kind of let me move it a second ago, but I think that was just a fluke. I don't think it's actually supposed to let me move the circles. But I've seen one of the circles over here and one of the circles over here. As long as when it curls back together, there's 1 circle on each side. That's all we're looking for. So for B, the net would be this guy over here. And then for a pyramid, so we have a rectangular pyramid or a square pyramid. So we can see here's a square pyramid with 3 triangles, and the triangles are a little, I guess, more stretched out than these ones, but it's not really a big deal. It doesn't really matter that the triangles are a little bit bigger. So we still have that same guy. And if I take this and if I fold it up, I can see that that definitely creates a pyramid. And all I can see now is the square. Because that's, if I'm looking straight down at it, I don't see any more. It's not flattened out. But now if I open it up and I flattened it out, I can see the triangle's flattened out on the ground. But this is the square looking straight down at it. And then I can see that pyramid. So we can see that C and 1 definitely match up there. So again, hopefully we're doing this in class. I know I'm going to be doing it in class with my students, and I've done it before in previous lessons. So it's definitely very cool to get to play with these shapes instead of just, you know, kind of listening or seeing it. You actually get to open them and see these nets that they create. All right, let's go to number 2. So I'm going to close this guy down because we're actually going to look at this. So surface area of a cylinder, which is the name of this section, right? With the height of 9 yards. So we want to know, what is the surface area? And first of all, what is surface area? What does that mean? We've been dealing with volume. Volume has to do with, like, if I fill this can with liquid, what is it? How much does it hold? How much liquid can it hold? Well, when I'm talking about surface area, if I'm thinking about a can, it's all the surfaces on the outside that I can actually touch and the area that they take up. So I want to know the entire area of this space around the outside, and then also the 2 circles on the end, the 2 bases. So I'm just asking, what's the area all the way around? And this is definitely a very important question when we're talking about, say, advertising on a can, especially when we're asking about the surface area around the lateral surface area, if I'm being very technical here, because I would want to know how much surface do I need to cover to go all the way around the can. That definitely matters. You wouldn't want to cut it short. That would look really funny. So this is definitely one of those questions. Many companies use this idea of surface area. So we want to find the surface area of a cylinder with a height of 9 and a base radius of 4. Use pi, the value 3.14 for pi, and do not do any rounding. So let's take a look at the net really quick of a cylinder. So it's going to be something like that. If I were to cut this guy right down the center here and peel it open, here's what it would look like. I'd have two circles and a rectangle. So if I want the surface area, I want to find the area of each piece. Now, if I'm thinking about the circles, should they be the same size circles or different circles? I'm really hoping we answered same size circles, because the top of the can and the bottom of the can should be the same size circles. Now I know if we're looking at like a bottle of soda, that the top circle that you screw off the cap, that's not going to be the same as the bottom. But what we're talking about is kind of the before it narrows to the top of the bottle there, it's going to be the same size circle. So, you know, we're not getting so technical that we're going up to the top of the bottle there. We're more looking at the can. So same size circles. So whatever this area is, this one's going to be the same, right? So these guys will be the same area. So I can find the area of 1 and multiply by 2 because it's the same area. So sorry, that wasn't a very nice airbrushing for whatever reason. I don't know why the airbrush didn't come out a little nicer than that. I think I have the airbrush too small. That might be why. So normally it's a little bit more fuzzy looking like that, a little bit nicer. All right. So area of a circle, and we've been doing this a lot, so area is pi r squared. Area of a rectangle is length times width. All right, so now we need to apply a little bit more because we don't actually have all the information we need here, do we? So I know what pi is. Pi is 3.14. And I know what the radius is. That's 4. So I can find the area of the circles. I can definitely find the area. Sorry, that was an equal sign. I'll find the area of the circles, and once I find this area, I'm going to times 2 because I have 2 of them. So now let's think about the area of the rectangle before we go and calculate this. So length times width. Well, if I cut straight down this one, we're going to pretend like we're cutting right here, where it says 9. That would be this guy here, 9 yards. So I already know that it's 9 yards this way, and I really hope this is not a soda can, because 9 yards, holy cow, that is a big old soda can. So we're talking about something else, not a soda can. Definitely a very large cylinder here. So we have 9 yards here, but what's the width then? So if we think about it, when we were expanding that circle for a cylinder, if we picture this guy closed, it's going around the circle here, right? And if I open it, you can kind of see this is still the circle shape. And that's what this length is the length around the circle. So I need to know circumference as well, because that's what this distance is. So the circumference of a circle is 2 pi r. So circumference equals 2 pi r. So this is another equation that we need to know in order to complete this problem. So length is going to be 9, and then width is going to be 2 times pi times r, which is 4. So we have a couple of things to calculate here. So now let's go ahead and do this calculation. We're going to have 3.14 times 4 squared, which is 16. I'm just going to go ahead and type in 16 instead of having to type in the square. So, because 4 times 4 is 16, equal, why did I move from there? So this is 50.24. This is also 50.24, right? They're both 50.24 yards squared. This is squared. This is just an area. We're not finding volume anymore. We're finding area again. So I can go times 2, and I have 100.48. This is the area of the circles. Now I need the area of kind of the rectangle or the midsection there. So I'm going to go 9 times 2 times 3.14 times 4, so I have all 4 pieces here, equals 226.08. And that's again yards squared, because this had yards, and this also had yards on it for the radius. So yards times yards still gives yards squared because it's still just an area. So this is the rectangle. So now I have both pieces, and I need to add them together. So 100.48 equals, and it says do not do any rounding again. Make sure you're paying attention to that. But it also says be sure to include the correct unit. It doesn't have it there. I need to make sure I select yards squared. Alrighty, so that was section 4. I will see you in section 5.